Hello everyone, I'm Jahanvi Maurya, roll number 215056, and today I will be taking up the topic motion in a plane and central orbit with application by Kepler's law. Motion on plane curves. Motion on smooth plane curves. Let us suppose the position of particle on the curve at any time t be p x, y with arc length s measured from a fixed point p1. Let v be the velocity at p and capital X, capital Y are the components of forces acting on the particle along coordinate axes. A normal reaction R acts at p on the particle because the curve is smooth. On resolving the forces along the tangent at P, the motion is given by cos phi is equals to dx upon ds, sin phi is equals to dy upon ds. But then we have mv dv upon ds is equals to capital X dx upon ds plus capital Y dy upon ds. Integrating with respect to s, we get the following equation as equation 2. Let us take capital X dx plus capital Y dy is equals to phi small x comma y. Then capital X and capital Y are given. Then we have the following equation as equation 3. Here phi x comma y is known as work function and half mv square gives the kinetic energy of particle at P whose coordinate are x comma y. Now let's initially the particle of mass m starts the motion with velocity v naught from the point P x naught comma y naught. Then equation 3 gives half mv naught square is equals to phi x naught comma y naught plus c1 as equation 4. From 3 and 4 we have the given equation as equation 5. So the right hand side of equation 5 shows the work done in moving the particle from P whose coordinate are x naught comma y naught to P x comma y, whereas the left hand side shows the change in kinetic energy of the particle. So the change in kinetic energy is equal to work done by total external forces. The equation 5 is energy equation and the force of this types are known as conservative forces. The potential energy of particle is given by formula potential energy at P is equals to integration from x comma y to x dash comma y dash capital X dx plus capital Y dy, where x dash comma y dash be the standard position of particle and x comma y be the position of particle from which it moves to x dash y dash. Now coming to central orbit. Central force, a force which is always directed towards a fixed point, is known as central force. The fixed point is known as center of force. The path described by particle under the action of central force is known as central orbit. Central orbit in a plane curve. Let the particle moves under a central force MP with O as the center of the force. The force acting along AO, the equation of motion will be given as follow. But force acts along the radius vector, that is minus r, then the following equation we will get. On integrating, we have r cross dr upon dt is equals to c, where c is constant vector. Taking dot product of 1 with r, we get r dot c is equals to 0. Equation 2 shows that the radius vector OA is perpendicular to a fixed direction C and hence lies in a plane. Now coming to Kepler's law of motion. Each planet describes an eclipse having the Sun in one of its foci. The radius vector drawn from the Sun to the planet describes equal areas in equal time. The square of periodic time of various planets are proportional to the cubes of major axes of the orbit. The second law says that the aerial velocity is constant, or r square theta is equals to constant. Hence, the force of planet is entirely directed to the Sun. From the first law it follows that the force on the planet is inversely proportional to square of its distance from Sun. From third law it follows, since T is equals to 2 pi upon under root u into a power 3 by 2, that u is constant, that is acceleration at unit distance from the Sun is same for all planets. Thank you everyone.